Assalamualaikum warahmatullahi taala wabarakatuh and good morning. I'm Dr. Sababau from the Physics Section, Pusat Pengajian Pendidikan Jarak Jauh, University Science Malaysia. This is course JIF 318, Quantum Mechanics. We are in Chapter 4, Solutions of One-Dimensional Time-Independent Schrödinger Equation. This is segment unit 4.6, Unbound States, Application of Tunneling. Basically, we would like you to describe at least two applications of the tunneling effect. Okay, we have studied or learned about tunneling effect. Then now where it can be applied. Here we will just discuss two applications. The first one is in alpha decay process. Okay, tunneling is seen on the nuclear scale because we are talking about alpha particle which originates from the nucleus. The potential seen by an alpha particle are short-range attractive nuclear force. Yes, it is inside the nucleus. So whatever particle inside the nucleus are bound by the strong nuclear force, and also the Coulomb repulsion from the remainder of the nucleus. There are two forces. Okay, the first one is the nuclear force, which bind together all the nucleons, and the second is the Coulomb repulsion from the remainder of the nucleus. Alpha particle is positively charged. Inside the nucleus you have protons, which are also positively charged. So there is a Coulomb repulsion among this alpha particle and the protons inside the nucleus. The total energy E of the emitted alpha particle is lower than the height of the potential barrier. Remember that previously we had discussed if E is smaller than the barrier or the potential of the barrier, then basically the particles or the alpha particle will be confined inside the nucleus. But since the wave function is not zero inside the barrier itself, so there is a probability the alpha particle can tunnel through, as we had discussed in the previous segment. So, however, in classical physics, alpha particle should not be able to go out of the nucleus because of the potential barrier. But the only way to escape is by quantum mechanical tunneling. That's mean by using considering quantum mechanics, then we can explain why alpha particle do come out of the nucleus, even though they have a potential wall. So this is the schematic diagram. You can see the potential is negative inside the nucleus. At the boundary of the nucleus, it goes up to positive. Then it slowly decreases outside of the nucleus. Okay, that's the potential of nucleus until to the outside of the nucleus. Our alpha particle have energy E, which is lower than the potential barrier here. This is what we call potential barrier here. So the alpha particle should be confined inside the nucleus only. But in the previous segment, we had discussed that if the potential is finite, you can see here that this is the distance which the thickness of the barrier which the alpha particle needs to penetrate. So if the potential well or potential barrier is finite, then there is a probability that the alpha particle can be brought out of the nucleus by tunneling through the potential barrier, like this. Okay. The second application is in tunneling diode. We have diode, but it has tunneling properties. Over a certain range in applied voltage, electrons tunnel through a potential barrier. Tunneling current increases with maximum voltage up to with applied voltage. With applied voltage, I mean when you apply voltage to the ends of the diode, the voltage goes up, then to a maximum value, and then decreases with increasing voltage. That means the current will not increase independently, or will not increase as at proportional ratio with the increasing voltage. That means you increase the voltage, the tunneling current will go up, but suddenly it reaches a maximum point and goes down, even though the voltage, the applied voltage is increasing in value. Over some range in applied voltage, the current decreases as the voltage increases. That means this is due to the tunneling effect. So even though we increase the voltage, the current after some time will decrease. So in conclusion, the emission of alpha particles during an alpha decay is due to their ability to tunnel through, I think there is one spelling mistake here, TH, should be H here, okay, through a potential barrier, okay. In tunneling diode, tunneling current increases up to a maximum value and then decreases with increasing applied voltage. Thank you very much for your attention.